that didn't get those calculators that I asked. But the word geometry, geo, do you know what geo stands for? You're standing on it right now. Earth, metry, you know what metry stands for? Measure, not math, but measure. So measure of Earth. That's what geometry is in the simplest form in our first incarnation of mathematics back in the ancient times. Geometry was a mystical thing because it was a way to try to understand the world that we lived in and around us. Geometry, measurement of Earth, geomeasure. And the circle is one of the more mystifying uh, objects. The pi thing. Where does this pi? How can I get a circle that's this big and one that's this big? And then when I take the diameter divided by, the circumference divided by the diameter of these measurements, I would always come to this one number, 3.14. They didn't get to that number right away. They didn't know really what decimals were back in the day. It was all fractions. So that mystified them. So anyway, we see circles everywhere in the environment. We have near circular orbits in this, as far as our planet is concerned, but it isn't. It's actually elliptical, almost circular. So that's why we're going to do ellipses as well. And then, of course, circles, and they're all over in architecture and all this other stuff. Just trying to give you an idea of why we do these things. Conic sections, some other ones, parabolic. There's actually some parabolic. A comet has a parabolic orbit when it flips around the sun and shoots back out into space. And then hyperbolas. I've heard radio waves kind of go hyperbolic in nature. So this is why we study these things. And of course, all of them can be attributed to architecture as well. So a lot of different applications for it. So what is it that I'm going to show you next is an equation of a circle in a coordinate plane. So this is a drawing of a circle with an x and a y axis. Got to breathe more. And then actually, this is based off of the distance formula, which is actually based off of the Pythagorean theorem. Who I wore that shirt last week. Did anyone notice my shirt last week with the two guys fighting for c squared? Nobody? All right. That was Pythagoras fighting with Einstein for the c squared, and they're two important formulas. Pythagoras uses it for a squared plus b squared equals c squared. And that's for a right triangle. Well, how does that apply to this? This is a circle, Mr. Samulus. Well, this is where the distance formula comes from. You actually create a right triangle out of these two coordinates. And then I could show you how the distance formula comes into play and then how this makes an equation of a circle. It's all intertwined. This x coordinate right here, I ended up calling h. You're going to see h comma k be very important coordinates the rest of this chapter. All right? So that's why we use the letter H for that one. The letter H. I feel like Elmo. And then this is x as far as an x coordinate is concerned. I just called that x comma y, so there's where x is on the x-axis. Floating this way, this is k, the y value, distance. And then I got to extend this up a little bit. This is whereabouts where y is. So if you were moving on a coordinate plane, you can see where those coordinates are and know where I'm coming from here. So what is A? Perhaps I could color code this. That we'll call this side. Like that's what I'm trying to say. A squared, that's A. Where does that come from? Or how do I get it in this coordinate plane? It's all of this minus this. So it's just that yellow. So it's all of x minus h. That is what the length of that one side is. So that is what I'm going to plug in for A. X minus h. Squared, because that's what it is. It's squared. And then the same idea here. This is all, poor Ivo here, I'm in his way. I see him leaning over for the notes here. All of y minus all of k. So what is the distance there? Just the yellow, which is y minus k. So this is why we get the distance formula. That's what I'm covering right now. This is what the distance squared is of that. But then we square root that for the distance formula. because that's what the c squared is. I just want c. And don't worry about, don't get confused what d is as far as circles, though d stands for distance. But what is this called for a circle? It starts with an r. What's that called? That starts with an r. Radius. So I'm going to turn that into radius. But then I'm going to flip it around and unsquare it again. What I wanted to do was compare it to the distance formula, which this really is the distance formula. And that distance is r. But here's what they treat as the equation of a circle that we're going to know. Back to squaring both sides. By the way, input, say it. I guarantee input-output does create a circle when you input-output certain coordinates. Guaranteed. And that's why this equation does create a circle. So I went back to squaring. I got out of the distance formula, squared both sides, and then we get our standard form of an equation of a circle in a coordinate plane. By the way, this is often messed up. If the center is 0, 0, then it's just x squared plus y squared equals r squared. And that should make a lot of sense, although students often screw this up. When they see x squared, they tend to try to say the center is 1, comma 1. It's a very common error. No, it's x minus 0. 0 is the center, comma y minus 0, 0. So 0, comma 0. So make sure you don't make that mistake of trying to do common error things. Okay, just taking a moment to let you write that down. Our first conic section. Our book doesn't have circles as a conic section, but it is a conic section, so we do have to add the section in there and add it to our situation. The math tours, they do have circles in it. We're doing ellipses. They're like a day ahead of you on conic sections now. It just happens to overlap. We got a kind of cool thing for Mr. Samus, but then sometimes I get confused. Which class am I in? What am I teaching? Not really, but it is kind of funny from day to day. All right, and then the first questions are quite redonkulous. And I lost something here, so I got to put this in here. Let's say like 0.7. I think that's what I used to have there. Okay, so you may not want to write this down. This is pretty basic here. But I have questions where I ask you, just from this information, what is the equation of the circle then? Well, I just told you 0, comma 0, that's x squared plus y squared. That's the pen going crazy on me on this squared here. There are no x, h, and k components, or there's 0. If you wrote x minus 0 squared and y minus 0 squared, I'd be okay. And then radius of 3, that means this is 9. You square 3, it's the radius squared in that position. So Mickey Mouse, this is what would happen. To graph this, all I would do is go 0, 0, and I go up 3, down 3, right 3, left 3. Those are 4 points that would make my circle. By the way, input, output, 0, comma 3 if I went up 3. What's 0 squared? 3, 2, 1, go. 0. What's 3 squared? 3, 2, 1, go. 9. What's 0 plus 9? 9. That's why 0, 3, 3, 0, 0, negative 3, and negative 3, 0 are all solution points. Therefore, they are on the circle itself and create the circle. So that's what graphing is. Input, say it. All right, and that's true. By the way, is a circle a function? 3, 2, 1, go. No, what does it fail? Vertical line test. As a matter of fact, all of these, except for a parabola going up and down, up or down, are non-functions. So this is a non-function chapter. It's not a dysfunctional chapter. Yeah. Plus y minus 7 squared. So opposites. Okay, so you got to play the opposite game in all cases for this. By the way, the center is not a solution point. The center is not on the circle itself. It just helps generate it. So do understand that the center is not a solution point. And you can prove that right there. I plug in 7, I get 0. 0 does not equal 5. Right? So it's not on the circle itself. It just helps generate it. And then the whole idea of this, just getting the Mickey Mouse stuff done. This is x minus or plus 3. 3, 2, 1, go. Plus, for those paying attention. All right, squared. And then 5, what is it? Plus or minus 5? 3, 2, 1, go. minus 5. And then what goes over here? Is it 4 or 16? 3, 2, 1, go. It's 16 just because that's the formula. It's the radius squared, and then you got to read it as the radius one way or the other if you had to graph it. I'm not even going to graph this one, and actually I'm going to blacken all this out because actually it's a lot easier than this, what I have written here. I'm not graphing this one right now. We have a graphing later. I'm tired. Okay, center and a pass-through point. Okay, so here's all you got to do. You got to understand in your mind, okay, I got to have this memorized. And by the way, we're doing ellipses next because the equations are so similar. We kind of go out of order with the book. I don't know if I should have actually, because we're doing a different order in the math tours, and I like the order that we did in the other class. So I don't know, but you got to have them all memorized, so it doesn't really matter. We can, it's all fine. What's wrong? My letters look bad? Okay. Oh, I put plus K. You're right. I'm trying to do two things at once, and I crashed and burned. All right, so the center, we should have no problem that this is plus minus a negative 2, so that's plus 2 here. And then this is minus a negative, which is plus 4 here. And that should be understood. Oh, and then passes through, that means that's a solution point. So I'm able to plug that in for x and y. So I'm able to plug in 1 for x and plug in negative 1 for y, and hence that just leaves me whatever r squared is. The question for all of these is find the equation, not really graph, just find the equation. That's why I don't want to graph it. I do want to graph the next one, though, for common sense purposes. 1 plus 2 is 3, 3 squared is 9. Negative 1 plus 4 is 3 again, 3 squared is 9 again. Now, not to trick you, but understand that we need a final answer. So I got to bring the x back. The x is the infinite amount of x's that can be solution points. But the center is the center for this circle, and it will always be 2 there because the center value is negative 2 for x. And then I got to bring the y back so that I can create all the circle's points, the infinite amount of y's that could be plugged in. But the center is the center. Now here's my trick. What do I put here? Do I put 18 or do I put the square root of 18? 3, 2, 1, go. Oh, I heard half and half. It's r squared. We just put 18 there. This is why I stopped. I didn't have to find the radius. I need the radius squared in that position. Fine, the radius is the square root of 18. How would I use that? Get a decimal. Just take the square root of 18 on your calculator, get approximately 4 point whatever, and then move up 4 point whatever, up, down, right, and left for the other points. But do understand what goes in this position. What goes in this position is r squared, not r, for the equation of a circle. That's why I just stopped there and added 9 plus 9, and that's the number I need. Don't need to do anything else. They didn't ask me to graph. So I won't. All right, but this one I am going to graph. But you know what I'm going to do? I'm going to get rid of all this rigmarole that I have here. It's a lot easier. It's a lot easier. So I'm going to get like some black space here to write on. Let me see if I can get a pen. Let's see if I can do this. I was crying last hour that I lost my ability to some of my pens I had last year. I had a yellow pen. Oh, what's this? Is this a pen? No, this is a. Okay, let's try this. This is going to get ugly. Okay, so let's go in here. Let's go to this box. I thought if I hit that box, oh, color and thickness. Let's see, color. Let's go yellow. Let's do like that. Oh, let's do a pen, and then let's add that. Okay, where does that? Yay! All right, so okay, here we go. All right, I'm so excited. I did something and I accomplished something technologically. Okay, diameter. Do we know what? Oh no! I gotta run and go sit at the desk. I gotta tether myself to the electricity. Oh dear. Okay, I got so many piles of papers here too. Okay, sorry everyone that I have to do this. Oh gosh. Okay, at least we can still see the screen. All right, is everyone okay? All right. What are you doing on your computer over there? Okay. Did I post the notes already? No answer. Okay. Good question. All right. So what's a diameter? It's 2 watts. I'm running out of time. 3, 2, 1, go. What's the diameter? 2 what? 2 radii. So I'm actually going to graph this one. -2, -3. This really makes me sad, and I do need to make this a red. I got to do yellow when I do my work over there. And then 4, comma 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. They call you robots sometimes because you've been trained this way mathematically. What's the formula? How do I get the right answers? All right, and that's how we attack things. And we need to do better on that. Because what I need then, how do I get the center? Where's the center compared to these diameter points? Right in the 3, 2, 1, go. Middle. So I need the midpoint formula. This is what I mean about robots. Like, oh, there's a formula for this. Is it plus or minus the y's? What the heck just happened there? Did anyone see that flash, or was that just me freaking out? So the midpoint, is it broke? Oh, for the love of dog. I just been sabotaged again. Hold on, video. Technology! Sorry. That was a student that screamed that, not me. Okay, I just got disconnected from the screen randomly, so I got to interrupt the notes. Had a hard time keeping people's attention when these stupid things happen. Someone's on their phone right away, right when that happens. Look at that. Ooh, I just got to check my text real quick. Love it. Okay, so we had to connect. Oh, you get to see all that on the screen, what I just had to go through again. Get all those texts checked? All right. Okay, so midpoint is actually add the x's. And then here's the robots. If you subtracted, do you ever check if your answer even makes remote sense of being the midpoint between these other 2 points? I bet you a lot of times we don't even allow ourselves to think about that. So this becomes 2 divided by 2, which is 1. So I guess I'll put that here, center, right here. And then -3 plus 2, or 5 is 2 again. 2 divided by 2 is 1. And then look, by golly, where 1, comma 1 is. Doesn't that look like it's exactly in between those other 2 points that I graphed? And I think we should be able to think about it sometimes, because when you subtract those two instead of add, the number's like in quadrant 3. How could that be in quadrant 3 and be in between those other 2 points? There's no way. I think it'd be quadrant 3. Yeah, if you subtract it, you get -6 over. You get -3, comma -4. Here's -3, comma -4. It's not even in between those 2 points, and that's where I question those that don't really think about what they're doing. So really make sure that happens. And then I will tell you, I made a mistake last hour. Now, what do I do to find the radius? I'm sorry, what do I do next? Exactly what we did in the last question. Okay, we want the distance from that point to that point. That's the radius. Or we just want to insert our values into our equation of a circle. So now that I have the center, I can put the center in for h and k, and I can pick any of the other 2 coordinates for x and y. And I choose the 4, 5. So 4 minus 1 squared plus 5 minus 1 squared. And conveniently, this becomes 3 squared plus 4 squared, which equals 5 squared, 25. So I got my final answer. You could do the 3 squared is 9, 4 squared 16, 9 plus 4 is 25. So x minus 1, y minus 1 equals 25 over here. Not 5. 5 squared, 25. You want the r squared number right there. All right, ain't no thing, chicken wings. Okay, ridiculous, and then graph. What's the center of the first one as you're writing this down? 3, 2, 1, go. 0, 0. Not 1, 1, whoever said that. Get that math out of your mind. What's the center of the second one? 3, 2, 1, go. -2, comma. Thirsty, sorry. Whew. Kids can drink water in here too. We don't care. Okay, so people in my 4th hour, they start trying to do picnics. I had to stop them from that. Anyway, and there we go. 0, 0, 4 up, 4 down, 4 right, 4 left. -2, 3, and then 3 up, 3 down, 3 right, 3 left. And now we're going to play input. Say it. Output. 1 comma 2 apparently is an input output. Let's go ahead and throw that in there. 1 plus 2 is 3. 3 squared is 9. Nice. 2, wait a minute. That's 1 comma 3. I never was good at counting. And I knew this was wrong because I was going to input and it wasn't working out right. So I did go up 3. I'm not cheating. It is up 3, not up 2. So my bad on that one. 3 minus 3 is 0. 9 plus 0 is 9. Check. And then just check this one down here. This is -2 comma 0. When I put that in there, oh, that's nice. -2 plus 2 is 0 squared. 0. 0 minus 3 is -3 squared, which is 9. 0 plus 9 is 9. That's another check. And I could go this one and check it and this one. Now, how do you get these other points? Kind of hard. You'd have to plug in a number for y and solve for x or vice versa. But those are the ones you can find. Up, down, right, left are pretty easy. All right, now we're getting somewhere. You want to get nuts? Let's get nuts. And I'm not doing this one because it's too easy. Now what we have to do is introduce something that I've got. See, a student just took a drink of water, and I'm okay with that, right? That's water, right? Yeah. Okay. That used to be the problem, by the way. These two jamokes, and this is why we have rules and laws, because people can't live in a society without screwing up and ruining it for everybody else. So these two jamokes one day sharing a water bottle. First of all, gross, right? This is pre-COVID. You know why they were sharing that water bottle? What do you think was actually in that water bottle? We're not stupid here, are we? Well, those people got caught, yeah. So this is why we don't allow water bottles a lot of times, because students just can't do it. There's also the water bottle explosion incident about 8-9 years ago. Do you guys remember that? We were in the news for that. Anyone know about that? Raise your hand if you do. Yeah. So we overreacted to that because a kid in freshman put some chemicals that exploded, and we ended up on the channel 2, 5, and 7 news as near national news that a water bottle exploded in a school, in a high school. All right. Yep. So that was another one. So if you ever wonder why, that was a thing, there's reasons, just like these laws that we have for things that, most people say, oh, I wouldn't do that anyway. Why do we need a law for that? Well, it's because people can't function. Okay, so anyway, that's an interesting little subject matter in the middle of circle notes. All brought on by someone lifting up that water bottle and drinking, right? And I did so myself. So that's what we're trying to accomplish, right? Our brand new equation of a circle. So first of all, if you stare at this, I asked this question and about half, maybe a little less than half got this right last hour. What do you think the y coordinate of the center will be? 3, 2, 1, go. 0. There's nothing else with y squared, right? Y squared is like Mr. Samulus, no friends. It's all away from him. Go away. All right? But the x squared has a 6x, so I'm going to have to do something about it. And it's going to be the glory and power of completing the square. Good foiler, say it. I'm just reviewing. When I say inverse, you say switch x and y. What's another one? Whatever we do to one side? What else? Input. We got another one coming. You ready? Are you excited? All right. So we're going to, okay. So whatever I do to one side, say it again. Do to the other. So I'm going to add a number to the left side. So I do have to add that same number to the right side. So whatever I do to one side, I do to the other. We just played that game. What number am I going to put there? Well, I want to put a number there so that when I'm done, I get a perfect square trinomial, and it'll factor to be binomial times itself. That's the objective. And I bet you a lot of the people are going to think about what number I'd put in that blank. Anyone know? Just yell it out loud if you know it. 9. It's 9. Here's how you get 9, though, if you can't just imagine what it would be. Here's the process of complete a square. Repeat after me. Take half the middle term. Say it. We got to start over because bums don't do it. So one more time. When I say complete the square, you say take half the middle term and then square it. So when I say complete the square, you say it one more time. Take half the middle term, and then, doesn't it sound like fun? And then what, class? Square. She doesn't seem impressed at all. Square it. All right, who's this for? Samantha. Okay, here you go. See her get out of here as quick as possible. All right, -3 squared. 9. Whatever I do to one side, to do the other. 9's got to go on that side. And then here's why. You just created a perfect factoring situation. What multiplies a 9 and adds to -6? What are those two numbers? What multiplies a 9, those same two numbers add to be -6. -3 and -3. I'm going to write this annoyingly one more time and talk about good FOILers, good factors one more time. This means this factors to be this. Then really you just ignore all the other stuff as secondary things. It's not part of this factoring. I can go ahead and add 9 plus 1. No, I think it's later. Right? Or does it say now, or does it say immediately? Or let's just wait till after I'm done with the notes, and then we'll go. And then for purposes of matching circles, this is x minus 3 squared. And therefore, I have my equation that I just introduced to you in the correct format. So here we are factoring again. And those that have not learned how to factor, you're doomed again. And I know I sound mean, but I've been teaching factoring since August, and then it's